Well, I'm not sure its application is, I will say, more speaking about a research agenda. Indeed, considering what has been said during the session on unilateral effect, I have observed that in one way or in another, there are some quantification that is used to predict price change due to a merger. I observed that the last three speakers spoke about coordinated effect, but did not refer to any quantification. And because it's a complex question, and it's really on the agenda, on our research agenda, and I'm just going to tell you some elements that are on the debate. It's complicated because what we have to predict is the risk of coordinated effect. So I'm not, after what Joe, the picture has given us to the theory, I would just say that I'll try to summarize what we can get from the theory in terms of necessary conditions that we could start with to set up test. And indeed, one important aspect is that there need a element of exchange of information between a firm to measure the effect of creating the condition for collusion or for coordination. So these are the four necessary conditions, and you can see that they call for a dynamic test cast in a dynamic perspective, which make indeed the agenda, the research quite complicated. As a matter of fact, so I wrote with my colleague a survey, and what I observed that in all coordinated effect cases, what people are trying to see is whether there are circumstances that are met to satisfy these necessary conditions that, and there are several. But in fact, these circumstances are not necessary, not sufficient condition. Okay, so what I'm not going into all the details of this, but you know these different elements linked to the number of competitors, the fact you have a growing market or multi-market contact, and all those things that indeed can give a support for coordination. In the literature, I will say there are three types of tests that you probably are aware of. It's the papers on cartel stability, following the paper by Porter. And this paper compare situation with and without tacit coordination. One of the technical problems there is how to detect when you go from one of these and usually the problem is, the technical problem is that you have to look at prices and say, well, here a period where you have stability and you have competition, and here is a period where you have collusion. So I don't want to oversimplify, but in this literature, there's been always some kind of adhocery to define the period of collusion, and this problem has not been solved. in the sense, I think that it has motivated paper like the one by my colleague Tirol and Maskin Tirol that take into account and endogenize all these elements. I will come back on that. And then there is a conjectural variation approach. So the conjectural variation approach is very nice. You test for a parameter, a conductor parameter. The problem is the interpretation of this parameter. This parameter has many meaning, and so I'm not sure that we can draw something from this literature. When you get, first of all, it's very difficult to have this parameter equal to 0 or 1 from a statistical reason. So when you get it between 0 and 1, and you have this conduct parameter, say, having a value of 0.6, what can you say? It's maybe because of dynamic effect. You are getting a lot of element there. So really the interpretation of that it's quite complicated. Another approach that was initiated by the paper of Gasmi-Lafont-Riong is to compare equilibrium. So you compare collusion versus Stackelberg equilibrium, Bertrand competition, and you select the equilibrium that is the most relevant to represent the data generating process. That is the one that is the closest to represent what the model is doing. In fact, this literature is growing, and I disagree with Joe. I mean, people like Paques have work on the top of Maskin and Tirol, and have tried to develop econometrics for this model. I tell you, it's very complicated, very complex to estimate. We are far from getting something out of this literature right now. There is a lot of attempt, but I don't think right now we can use it as a way to test it. So it's for this reason. There are right now different propositions, and I think that there are two interesting propositions. One is what I call a structural test that was introduced by Sabatini, and then Peter Davis provide another version. The idea is, and it's linked to the necessary condition I was presenting. The idea is that the incentive to cooperate is captured by the incentive compatibility constraint that is linked to the dynamic game. That is to say, what is the constraint to make collusion sustainable? Okay. Which is a little bit different than the proposition made by Kovacic, which is to compare the profitability, that is the profit under collusion and under competition. So it's a little bit, and I will explain that. The interesting aspect is that it's a natural follow-up of the usage of simulation model that are used in unilateral effect. It's the same type of models that we can use and so can be applied for coordinated effect. Now there is also, I would say, I call it approximated test. Is my terminology and to represent that. So there is a proposition made by Moresi, Reitman, Salop, and Sarafidis on on an index very similar and very similar to the UPP. It's called the Coordinated Pricing Pressure Index, and the idea is really to have an index to support this new idea of parallel accommodating conduct that has been introduced in the horizontal merger guideline in 2010. And I will tell you a bit of what it is. Okay, so on the structural test, it's really based on the the old literature, or the first seminal paper on dynamic game model. And the idea is to compare the payoff under coordination and with defection. So the idea is written here. There is no incentive to deviate from collusion if the payoff under collusion is higher than under defection. What is the payoff under collusion? Is the discounted profit that you are going to get in all the period, and you compare to the profit that you will get if one of the firm cheat. That is to say, she will get all the profit, that's the profit of defection, and then the industry come back to equilibrium, and then the firm will get the Nash profit. Okay, so that is the idea will be to see how whether this condition is satisfied. So and then it's relatively, I will say, is straightforward in the sense that it follows the step of estimation and simulation of equilibrium model. So one of the solutions is to follow this procedure. So we estimate a differentiated product demand system. We talked about that earlier. We can assume that we can recover marginal cost using an assumption of Bertrand-Nash competition. And given that we have the marginal cost, that we have every element of the parameter of the demand, we can compute the price and the profit under Nash and collusive and collusion. We can also calculate the price and the profit for defection, in the sense that when there is defection, the firm will get all the profit. And so we can check whether the condition is satisfied and for which discount rate. And the idea is, if we obtain discount rates that are meaningful in the sense that they correspond to the business, then we can say that the test is realistic. It's very interesting to see what we can get with this test. For example, here is so I'm not going into the details. So there is 3 firms, and there is one firm with 4 products. So it's a big firm. And there's 2 firms having one product, okay? And so here you observe that the condition for collusion is satisfied when delta, the discount rate, is above 0.8, okay? And you see that collusion will be stable in this industry if the discount rate is that. Now, So it's the starting point. And now consider that the two small firms merge. Okay, nothing changed. Well, just a little bit of change. You see that previously the big firm started to be. It was better for the big firm to collude when the delta was higher than 0.4, and now is 0.5. So it's just saying that the model is working well, given that now the pressure for the bigger firm created by the two small firms is there. Okay, but otherwise nothing changed. Now look, and now the big firm merge with the small firm, and you can see that collusion is no more. The risk of collusion disappear. Okay, so of course it's an example, but because in this case the small firm is creating, in fact, enough competition, and the reason of that is that if you increase the asymmetry between firms, you increase, in this case, and with the assumptions that are behind this model, you increase the degree of competition. So it's just to explain that this test is interesting and can give some information about the working of an industry, but of course, to implement it, you need all the type of elements that are needed behind a simulated model. So, okay, now this approximated test called Coordinated Pricing Pressure Index. In this case, the idea is to assess whether firms are prone to parallel accommodating conduct, and so you have to. The idea is to compare the situation pre-merger and post-merger, and so you compute this index before and after, and the difference. Give you an idea of the capacity of the market to give the condition for coordination. So the intuition is very simple. The idea is to look at the largest price increase that a firm can implement, and that will be matched by by firm B, and the CPPI, the Coordinated Pricing Pressure Index, is the minimum of this two price increase. Oops, sorry. There is a problem of to compute the price increase. So there is the price increase of firm A that the firm A will implement. That's the formula. MA is the margin, and FA is linked to the diversion ratio. So you see, to compute the maximum price increase that firm A can sustain, you need basically the same type of data that you need for the UPP. And so you can compute this price increase for firm A and for firm B, and you take the minimum, and the minimum give you an idea of the pressure that you can make on the market. And so your capacity, in fact, together has put a price increase on the market. And so you do the computation pre-merger, post-merger, and you compute the difference of CPPI, and that gives you a measure of the likelihood of coordination of parallel accommodating behavior. So the nice thing is like for the UPP, you can do it with available data. It's true that it's based on simplifying assumption. You don't take into account efficiency. The only thing I can tell you is that it's a proposition that has been proposed by this author, but really it has not been applied yet, and it is on the agenda to be tested. And one thing that I would like to do is, in fact, to use my workbench to test it. But that will require also now to, of course, to go a little bit further and to have a model that takes into account the dynamics that we still do not have. Okay, thank you very much.